Hello everyone. This session, welcome to HTL Laboratory. This session, I'll be explaining HTL code to describe the functions of a full adder using three different types of modeling. So there are in HTL there are 5 types of modeling. In that we will be explaining here. We will be explaining about. I'll be explaining about 3 modeling styles. That is, one is data flow, behavioral, and structural. Okay, I'll be concentrating on 2 modeling styles. That is, one is behavioral and structural. So what is the objective of this program is to understand the concept of full adder, to realize and simulate full adder function using VHDL and Verilog. So let us come to the brief theory of full adder. What is a full adder? It is a combinational circuit that performs the addition of 2 bits. That is nothing but half adder. So one that performs the addition of 3 bits, that is 2 significant bits and the previous carry, which is nothing but your full adder. So the most basic arithmetic operation is the addition of 2 binary digits. This simple addition consists of 4 possible elementary operation, that is 0 plus 0, 0 plus 1, 1 plus 0 and 1 plus 1. So 1 plus 1 it will give a carry, that is 1. So sum will be of 0 for this combination. The first 3 operations produce a sum whose length is 1 digit, but when both augend and addend bits are equal to 1, then the binary sum consists of 2 digits. Higher significant bit is called carry. Okay, let us come to the block diagram. So for the structural description, we need the use of half adder. So by using 2 half adders and 1 OR gate, we will be writing a structural description of full adder. So this is the structural description, that is block diagram used for structural description of full adder. 2 half adders and 1 OR gate. So first half adder, input to the first adder is A, B, and outputs are S1 and C1. So for next half adder, the first input is the output of the first half adder, that is S1, and the one more input is, that is the actual input of full adder Cin. And what are the output to the second half adder? It is sum and C2. So what are the input to this OR gate? That is nothing but C2 and C1. Output of this OR gate will be the final carry out of your full adder, and sum is nothing but one of the output of full adder which is coming from the second half adder. Next, in order to write the behavioral description of full adder, just we require the block diagram like this. That is, we need 3 input A, B and C in, and 2 outputs S and C. Since it is a 3-bit input is of 3 bit, the total combinations will be 8, that is 0, 0, 0 to 1, 1, 1. For all the combinations, we will be calculating the result. So we will be getting the sum as well as carry out. Let us see the truth table of full adder. So this is the truth table of full adder. A, B, C in are the inputs and sum and carry out are the output. I'll explain one combination, that is 0, 1, 1. So how the addition is going to happen is 0 plus 1, the sum is 1. Again 1 plus 1, what is the sum? Sum is 0, whereas it will give 1 carry. So carry out will be 1. Now let us come to the simulation part. Open the Xilinx software and file, click on file, new project. First I'll explain about behavioral program. Okay, next, the procedure already you know, so I won't explain the procedure here in this session. Next, write a program in text file. Once you have written the program in text file, see how I have written the program here. That is, here also I have considered the behavioral description, that is A and B are the input to this, A, B and C are the input to the full adder, S and C are the output to the full adder. Okay, so inside the process we need to write down the sensitivity list of the full adder, that is A, B and C. Okay, next we have used the sequential statement here, that is if else if statements. So all the combinations are going to be explained using else if statements, and we have written the corresponding sum and carry out. This is a program. Once you have written the programs, save the program. While saving, give the save as type as VHDL only, because we have written the VHDL program. Click on save. Okay, once you save the program, add the text file. Right click on device, add source. Here the program has saved it as VEH. This is the file. Open that file. Click on OK. Next, what is the next step? It is to synthesize. Double click on synthesize. So it will take some time to synthesize the program. So wait for some amount of time. It will give you the, suppose the program consists of error, it will give you the error in the transcript window. Go through the errors and find out the error. Then again do the changes in the program, save the program, again come back to the same procedure, that is synthesize. So if the program does not contain any error, you can proceed with the further steps. Now warning is there, let it be. And now the next step is change the sources for implementation to behavioral simulation. Double click on create new source. You are going to create a test bench waveform. That is, give a name, next, finish. Okay. So this initial timing and clock wizard window will come. Go for this option, that is combinatorial. Click on finish. Okay. Here give the input, all the input combinations you can give, that is from 000 to 111. I will be giving few combinations, that is 000, 001, next 010, 011. Okay, this much is enough. Save this. After saving, come for sources, click on the test bench file and double click on simulate. Verify the output. It will take some time to simulate. Okay, verify the output now. See here, keep the cursor here. What is the input given? 001. So 0 plus 0 plus 1, what is the sum? 1. Carry will be 0. Next come to this 010. 0 plus 1 is 1. 1 plus 0 is 1. Sum is 1. Carry is 0. Next go to the next combination where 2 inputs are high. Yeah, you can check the output like this by giving different combinations of input. So this is about full adder. So we have come to an end of this. Thank you.